In this video, you're going to learn how to work with arithmetic sequences as well as series, and we're going to go through 9 problems together. So let's dive in and we'll talk about the different problems that you're likely to encounter and how to solve those types of problems. So the first thing we want to kind of look at is what exactly is a sequence? Well, a sequence is basically a list, and you can see these individual terms are separated by a comma. And if it's an arithmetic sequence, it means that you're adding or subtracting the same thing each time to get to the next term. Now, when you subtract, you can think of that as adding a negative number. So in this case, what do you think we're doing to get from 5 to 8 or 8 to 11? Well, you can see that we're adding 3, and that's referred to as D, which is the common difference. So we would say D equals 3. And if you want to double check, you just take any number minus the one before it. So 8 minus 5 is 3, 11 minus 8 is 3, etc. And you want to make sure that it's consistently adding that same number or subtracting that same number. Again, subtraction is like adding the opposite. Now, what's interesting here is the notation. So here I can say that n equals 1, but the value of that term we call a sub 1, like a subscript 1. Here's the second term, n equals 2, but the value of that second term we call a subscript 2 or a sub 2, etc. Now, if we want to write a formula or a rule to find any term in the sequence, what we can do is we can say, well, let's start with the first term. Okay, so we'll say a sub n equals our first term, which is 5, plus n minus 1 times our common difference 3. Now, let's see if we can understand why this works. Like, if I wanted to find, let's say, the 1, 2, 3, 4, 5, 6th term, well, because I'm already at this first term 5, 6 minus 1 is 5, so I'm really adding 3 5 times. See, to get to the 6th term, we're adding the common difference once, twice, 3 times, 4 times, 5 times. It's always one less than the term that you're interested in, and that's, again, because you're already on that first term. You're starting at that first term, so you just have to do it one less time. Now, what you want to do here is you want to simplify by distributing. So that gives us 3n minus 3 plus 5, combined like terms. So we get 3n plus 2 equals a sub n. So that means the value of the nth term. Now, if the problem says find the 20th term, which would be a sub 20 or a subscript 20, by putting 20 in here, we see that 3 times 20 is 60, plus 2 more equals 62. It takes you right to that term that you're interested in. Now, there's another way to write a formula for finding any term in the sequence. It's called a recursive formula, and it looks something like this, and I'll explain how this notation works. So you would tell the person or the computer, what's the first term? So what are you starting at? So the first term in this case is 5. And then you want to write what's called like a rule or a formula for finding the next term. So that's what we call recursive. You have to keep repeating to get to the next term, next term, next term. So we would say a sub n, the value of the nth term, equals the value of the a sub n minus 1, that's the term before it, plus the common difference. So in this case, the common difference is 3, because we're adding 3 each time. Now, if you want to check it, like say, for example, I want to find the 6th term, see, by putting 6 in here, a sub 6 equals a sub 6 minus 1, which this is really a sub 5. And so we take the value of the 5th term, which is 17, plus 3 more, and that's going to give us the value of the 6th term, which is equal to 20. So that's one way to do it. Another way to do it that you might see, instead of this notation, you might see it something like this. A sub 1 is equal to 5. A sub n plus 1, so that's saying like one term after the nth term. So you would take the nth term plus, in this case, 3. So again, let's say if we wanted to find the 6th term, I could make n 5 here. So that would be a sub 5 plus 1, which is a sub 6, equals a sub 5 plus 3. So if I want the 6th term, I go to the value of the 5th term, which is 17, plus 3 more, and that gives me the 6th term, which is 20. So either one of these forms, either the n plus 1, okay, or you could do this a sub n. Just remember, n minus 1 means the term 1 before, n plus 1 means the term after, and so this is called a recursive formula. Let's take a look at a few more examples. Okay, for number 2 now, let's see if we can find an explicit formula for this sequence, as well as a recursive formula, and let's see if we can find the next 3 terms in the sequence. So 3 questions here. So the first thing I would do is I would analyze this and say, is this an arithmetic sequence? Are we adding the same thing to get to the next term each time? And remember, that's actually called the common difference. Remember, difference in math means to subtract, right? So if you take the difference of -6 minus -10, you get 4. Or if you take 6 minus 2, you get 4. If you take any number minus the one before it, you should get that common difference of 4 in this case. So that looks to be the case. We're adding 4 each time. That's our common difference. Let's start with our explicit formula. Explicit takes you right to the answer, the term that you want. Remember, recursive, you have to keep repeating to get to the next term, next term, next term until you get to the term that you want. So let's say that a sub n equals a sub 1, the value of our first term, which is -10, plus n minus 1 times our common difference, which is 4. Now we're going to distribute the 4, so that's 4n minus 4. Combine like terms, -10 plus -4 gives us -14, and that's our explicit formula for this sequence. Now, sometimes I like to check my work. Say, for example, I want to find the 5th term. If I put 5 in here, 4 times 5 is 20, minus 14 is 6. See, it matches, so it checks out. Now, if I want to find the next 3 terms, that's pretty easy. We decided that we were adding 4 each time, so that means that this is going to be 10, this is going to be 14, this is going to be 18, etc. If we want to write it as a recursive formula, let's go ahead and put our bracket here. The first term we want to tell the computer or a person we're starting at -10. To get to the nth term, we have to take the previous term, the n minus 1th term, and we have to add that common difference of 4. And you can put a little note here that this is when n is greater than or equal to 2, meaning it works for the 2nd term, 3rd term, 4th term. If you want to test it out, like say for example, if I want to find the 1, 2, 3, 4, 5, 6th term, that means n is 6. 6 minus 1 is the value of the 5th term, okay, which you go 1 term back and you add 4 and you see if it matches. So you just kind of get used to the n minus 1 doesn't mean you're multiplying by n minus 1. It's a subscript, sub meaning below the line. It's telling you to go 1 term before. So you take that 1 term before, you add 4, you get 6. Or if you want this one, you go 1 term before, which is 6, you add 4, you get 10. That's one way. Remember, the other way to do it is to write it like this. Some teachers prefer this notation. You would write a sub n plus 1. So that means for the next term, you take the term that you're on, the nth term, and then you would add the common difference, which is 4. Now here I'm going to say n is greater than or equal to 1, because when I put 1 in here, 1 plus 1 is 2. So the value of the 2nd term, you take a sub 1, see n is equal to 1, that's the first term, and you add 4, and see how that gives you -6. So whichever method you prefer will work. And for number 3 now, let's look at this one. It says write the first 5 terms, and notice they're writing this arithmetic sequence recursively. So they give us the first term, so that's 7. If we want to find the next term, see the n plus 1th term, we take the term that we're on and we add 5 more, so this would be 12. Now some students might find this a little tricky, so what you could do is you could say, all right, I want n equals 3. So if I want n equals 3, to make this 3, I'd actually have to put a 2 in here, right? So 2 plus 1 is 3. The value of the 3rd term equals a sub 2, which that's the value of our 2nd term, plus 5 more, that's 17. After a while, you just get used to the notation. You'll say, oh, all I'm doing is to find the next term, I take the term I'm on and I'm adding 5. And once you're off and running, you just keep adding 5. So 22 and 27, etc. Let's take a look at some more examples. Okay, for number 4 now, we've got a sub 4 equals -8 and a sub 7 equals 10. So they're telling us the value of the 4th term, they're telling us the value of the 7th term. Let's say that this is an arithmetic sequence and we want to write an explicit rule for any term in this sequence. How would we do that? Sometimes what I like to do is diagram it out. So I can see, here's my 4th term, it'd be right here in this position. Here's my 7th term, it's 10. And I know it's arithmetic. I want to find out, what's a formula for finding any term. Well, we know that we're adding the common difference once, twice, 3 times. So what we could do is we could say negative 8 plus 3 common differences will equal 10. If I add 8 to both sides, 3d is equal to 18. And if I divide by 3, d is equal to 6. So that's our common difference. The only thing is we don't know what the first term is. So one thing we could do is we could say, let's go to our explicit formula now. The value of the fourth term, so a sub 4 equals a sub 1 plus 4 minus 1 times our common difference d, which is 6. So notice these ends match, okay? So this is our fourth term, this is the value of our fourth term. Now the value of our fourth term is negative 8, so we can solve for a sub 1, our value of our first term. So this is 3 times 6 is 18, plus a sub 1 equals negative 8. Subtract 18 from both sides, and you can see that a sub 1 equals negative 26. Okay, now we have everything we need. We have our first term, a sub 1. We have our common difference, which we said was 6. Let's put it all together. A sub n equals negative 26 plus n minus 1 times our common difference of 6. Let's simplify a little bit by distributing. And then let's combine like terms. So negative 26 plus negative 6 is equal to negative 32. And that's how you'd find the value of any term. Now, sometimes I like to check it just to make sure I didn't make a mistake. Say, for example, the seventh term, so 6 times 7 is 42 minus 32. Yes, that does equal 10. See, it matches. So that's just one way to do it. Another way to do this problem, if you want, is you could write a system of equations. So I'll show you the setup for that. So you could say, like we did here, we could say negative 8 is equal to the first term, which we don't know, plus n minus 1, so this would be 4 minus 1, which would be 3d. We can make another equation with this term here. We could say 10 is equal to a sub 1, which we don't know, plus 7 minus 1, which is 6d. So you have two variables, the first term and the common difference. You have two equations. You can solve this using substitution or elimination or graphing like that. So that's another way to find a1 and d. Let's take a look at number 5, a little different problem. It says find the sum of the first 100 integers. So now we're talking about sum. When we talk about the sum, it means we're adding up all the terms. So when you're adding up all the terms, that's referred to as a series. Okay, sequence is like a list with the commas. And so imagine if you were adding 1 plus 2 plus 3 plus 4 plus dot 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 plus 97 plus 98 plus 99 plus 100. It would take a long time to just add all those numbers together. But see if you can follow this pattern. If I take 1 plus 100, I get 101. If I take 2 times 99, I get 101. 3 times 98, I get 101. 4 times 97, I get 101. So if I take the first term and the last term, the second and second to last term, third and third to last term, I get that same number of 101. And how many 101s do you think we could make here? Well, there's 100 numbers, but because we're pairing them up 2 at a time, we should have half as many, right? So there should be 50 101s. So if we multiply these together, we should get 5,050. So that would be your sum. Now, that gives us some insight into where this formula here for finding the sum comes from. You take the number of terms, so in this case we had 100 divided by 2, so we had 50. 50 what? 50 of the first term and the nth term, meaning the last term, added together. So first term was 1, last term was 100, that was 101. We had half as many of those pairs, right? So let's take a look at some more examples. Number 6 now, it says find the 15th partial sum. Now, what do we mean when we say partial sum? Well, you can see this series, 3 plus 8 plus 13 plus 18 plus dot, dot, dot. It goes on forever and ever. So we're not looking for like an infinite sum here. We're looking just for like a part of this whole series, right? So we're going to add the 15 terms, the first 15 terms together. So what we could do is we could write this as s sub 15, so the sum of the first 15 terms, equals, I'm using this formula right here, the number of terms is 15 divided by 2 a sub 1 is the value of our first term, which we know is 3, plus the value of our last term. Now in this case, our last term is our 15th term. Well, we don't know what the 15th term is. How can we find it? Well, let's go back to our explicit formula, and let's use that to help us. So a sub 15 equals a sub 1, which is 3, plus n minus 1. So 15 minus 1 is 14, times our common difference, which is 5. You can see we're adding 5 each time. Okay, so that comes out to 70 plus 3 is 73. That's the value of our 15th term. So let's put that right here, and we've got it. So this is 76 times 7.5 equals the sum of our first 15 terms. Now, I'm going to do this on the calculator. You can do it by hand if you want. And this comes out to 570. So that's our partial sum. Okay, let's take a look at another example. Number 7, now we're introducing this sigma notation. See this fancy little e here? This is the Greek letter sigma, and it refers to finding the sum. And we want to look at this lower bound and this upper bound. So these are referred to as like the index. And the way this works is you start at this bottom number, you put it in for n, and that's going to be the value of your first term. So if I put 10 in here, 2 times 10 is 20, minus 3 is equal to 17. If I put 11 in here, 2 times 11 is 22, minus 3 is 19. Okay, etc. If I put in 40, 2 times 40 is 80, minus 3 is 77. Okay, so now let's take a look. We're trying to find the sum. How many terms are in our series? Well, how many terms are there from 10 to 40? Remember, the 10 and the 40 just refers to the 10th term, 11th term, all the way to the 40th term. How many terms? Now, a lot of people say, Mario, isn't that obvious? Isn't there 30 terms? 40 minus 10 is 30. But if I show you my hand here and I say, what's 5 minus 1? That's 4. But you can see there's 5 fingers that I'm holding up, right? So when you subtract, you have to add one more because you're including the first and the last term. So if you take 40 minus 10 is 30, plus one more. So we have 31 terms. If you don't believe me, count them out. 10, 11, 12, 13, all the way up to 40. You'll see there's 31 terms divided by 2 times the first term, which we said is 17. Remember, you just put 10 in here, this bottom index, to get the first term. Put the top one in, the upper bound, to get the last term or the nth term. And now we have everything we need. So 31 divided by 2 is 15.5. Let's see, that's 87 plus another 7 is 94. So what's 15.5 times 94? I'm getting 1,457. So this is 1,457. That's the sum. Let's take a look at 2 more examples. Okay, if you've stuck with me this far into this lesson, you must like the way that I explain things. And if you want to go deeper into Algebra 1 as well as Algebra 2 / college algebra concepts, I highly recommend both courses, the Algebra 1 as well as the Algebra 2 / college algebra course. I'll put links in the description below. Many students have taken these courses and benefited from the sequential order in which I take you through the different topics, one building on the next. And we go through things like sequences and series in that course, as well as many other topics. So take a look at the curriculum, and you'll see that it covers quite a bit of material. So check those out. And let's go through the last 2 examples together. So number 8, we have another one of these sigma notations or summation notations. And this is asking us to find the sum of this series. What I like to do sometimes is write out a few of the terms. So if I put 0 in here, negative 3 times 0 is 0. Plus 1 more is 1. So that's our first term. Then if I put 1 in, negative 3 times 1 is negative 3, plus 1 is negative 2. Then if I put 2 in, negative 3 times 2 is negative 6, plus 1 is negative 5. Dot, dot, dot. If I put 11 in, negative 33 plus 1 is negative 32. Now the reason I do that is because I want to just kind of identify the pattern here. I can see that I'm adding 3. Actually, let's see, we're subtracting 3 each time. So that's our common difference. So we know that D is equal to negative 3. It's an arithmetic series. And again, remember the way that this works. You start at this bottom index, you put 0 in, and get an answer. That's the value of your 0th term. Then you put the next number in, 1, you get the next term, 2, 3, 4, all the way up to 11. So this is what's referred to as the lower bound and the upper bound. Now, we're finding the sum of all these terms. We're going to be using this formula right here. How many terms are there in this series? Well, how many terms are there from 0 to 11? Well, you could count and find out, or you could do 11 minus 0 is 11, plus one more, which is 12. Or you could just say if it started at 1, 1 through 11 is obviously 11, like if you're counting 1, 2, 3 up to 11, but then you have to add 0, so there's 12. So let's do 12 divided by 2. The first term we said is 1. The nth term or the last term is negative 32. So we're getting 6 times negative 31, which is negative 186. That's your sum. Okay, let's go to number 9 now, the last problem. The sum of the first 30 terms of an arithmetic sequence with a common difference of 4 is 2,430. Find the first term. So it's kind of like a story problem here. And what's interesting about this problem is it's not asking us for the sum. It's actually giving us the sum. It's giving us the common difference, but it doesn't give us the first term. So let's go ahead and use this formula and let's put in what we know. So we have S sub 30, the sum of the first 30 terms, okay, equals 30 divided by 2. The first term we don't know. And let's see, we know the sum here, which is equal to 2,430. And we don't know this last term. Now we know there's 30 terms, so let's go to our explicit formula and let's say, okay, what's the value of the 30th term? Well, that would be a sub 1 plus 30 minus 1, which is 29, times the common difference of 4. Okay, so see how we did that? So this represents the nth term, or the last term. This is our first term, so first plus last, times the number of terms divided by 2 equals the total sum, which is 2,430. So let's simplify a little bit down here. So 2,430 equals 15. 30 divided by 2 is 15. We have 2 times a sub 1 plus, let's see, 30 times 4 is 120, minus 4 would be 116. Okay, and let's see, let's divide both sides by 15. So 2,430 divided by 15. Okay, that's 162. Let's just show our work here. So divide by 15, divide by 15. Let me bring this over here. 162 is equal to 2 times the first term plus 116. Let's subtract 116 from both sides. Okay. 46 equals 2 times a sub 1. Let's divide both sides by 2. And you can see that our first term, a sub 1, is equal to 23. And that's what they were looking for, the first term. You could check your work by plugging it back in. First term plus last term times the number of terms divided by 2, you should get 2,430, the sum. So great job if you're able to follow these 9 examples. If you want to go further into learning more about arithmetic sequences, arithmetic series, geometric sequences, geometric series, and infinite geometric series, I talk about all those topics in that video right there. So follow me through to that video. It's a complete guide. I'll see you in that video.